Okay, we're revisiting one-to-one. We saw this in linear algebra. Okay, so a function is one-to-one if and only if for every x in x1 and x2 in x, right? But here, starting from my x, if, notice where it starts, if I have this one y value, this is the same one y value where f of x1 equals f of x2, then when I go back, I'm at the same x value, right? So remember, you start here. This is the big deal. You start in the y values and you go back and you say, look at that, I'm at the same x value. Okay, it is not one-to-one if I start with the same y value and I go back and I can see that there's an x1 and there's an x2. So let me just give you an example. If you know that function x squared, f of -1 and 1 both give me this y value of 1, right? So this could be -1 and this could be 1. So this is not one-to-one. So let's just make sure we understand that one-to-one can be stated in two ways. If I start with the same y value, then I go back to the same x value. What's this? If not this, then not this. Contrapositive, which I know is logically equivalent, right? So true or false? If the function is a function is one-to-one, if and only if every element of x is sent by f to exactly one element of y. Where's the if starting? The if is starting in here, right? If starts here and goes to here, so this would be f of x1. So this is sent to exactly one element, right? This is false. This is false because you don't start in the x's, right? That's what this is saying. Don't start in the x's because that just says each one of these goes to one of these. Well, yeah, that's not true. Okay, so is this one-to-one? Is this function one-to-one? If it is, then what you need to show, what I'll need to show is that f of x1, if it equals f of x2, then I need to do work and then get to a point where I say x1 equals x2. So let's put x1 into the function. So 4x1 minus 1. Let's put x2 into the function. And now let's just do algebra. Add 1 to both sides, divide by 4, check. So I do end up getting it's one-to-one because when I start with the same y value, I end up with the same x value. Okay, so is it true? So this was for reals. Is it true for integers? So I need to show f of n1 equal f of n2. So again, I'm just going to use the function, add 1 to both sides, n1 equals n2, check. So it is one-to-one, right? Okay, so give a graph of a function that is one-to-one and one that is not one-to-one. I've kind of done this already, but let's just, anyway. So here, right, x1, x2, that would be a one-to-one function. So, and then to call this f of x1 and f of x2, right? So a function that is not one-to-one would be this, where f of x1 equals f of x2, but x1 does not equal x2. Okay, so this is not one-to-one, and this is one-to-one. Pictures, I think, can be very helpful.